Yeah, a good evening, class. And this is our automotive and power class. We're going to do the Laplace transform. And specifically, I'm going to introduce the Laplace transform, and I'm starting right away. Let's now get to our slide one. Obviously, you can now see it. We have introduction to Laplace and automotive and power class. Moving to the next slide. Yeah, Laplace transform. So when someone talks about Laplace transform, what do you understand? You realize Laplace is an integral transform, just like Fourier transform. And what do I mean by an integral transform? It is that very that very transform that has this form, and this is a form just like you can see in my slide. G as a function of alpha is equal to integral with limits a and b ft times k as a function of alpha and time dt. So before I talk about this that is down, let me first move to my next slide. Yeah, like you can now see, this form is in three functions. That's g as a function of alpha representing the output function, and f as a function of time representing the input function, then k as a function of alpha and time representing the integral canal. So let me move back a little bit. Yeah, you're all looking at this form. So this is an output function, then this is an input function, and this is an integral canal. It's important you remember this and grasp this form because we are going to refer to it. Yeah, so let me move to my other slide. Yeah, I'm sure you all still remember the Fourier transform formula, which is just here. I'm not going to revise through it, but it's this one. So now we're going to compare the Fourier transform with the general integral transform. So these both have the same form. That's the output function and the integral canal, like you can see, then the input function, you can all see. Yeah, then we go to the Laplace transform formula. This is exactly what we are supposed to talk about in the class, and this is what is important. The Laplace transform formula. It's equal to the integral of limits negative infinity to infinity exponent negative st or ft then dt. Let's talk about the complex variable s, which is just here. S is equal to sigma plus j omega. And what does sigma represent? It's the damping factor, and omega is a frequency in radians per second. Yeah, let me move to my next slide. Now we are going to compare the Laplace transform formula with the general integral formula. We talked about this. So both of these still have the same form, which is the output function, the integral canal, and the input function. Therefore, we need to, after doing all the analysis and after looking through all this, we realize that Laplace transform and Fourier transform are integral transforms, sorry, not functions, transforms. There is a very important note here, and we need to understand it. It's important. The Fourier transform does not exist for non-absolutely integrable signals, but the Laplace transform does exist for non-absolute integrable signals. So this is key. Remember, you should remember this. Now, this exists. Therefore, Laplace transform can be applied in a broader range of signals. Yeah, Laplace is in two forms. That's a bilateral Laplace transform and a unilateral Laplace transform. So these forms have a difference, which I'm going to explain after. But let's first look at the form. It's just like Laplace transform formula, but the limits are the difference. You realize the limits are negative infinity to infinity for the bilateral Laplace transform, and for the unilateral Laplace transform, the limits are from 0 to infinity. So that's the difference. There is these limits, this and this, but you also have to consider this. Uh, Now we have the inverse Laplace transform, and this is equal to 1 out of 2 pi j integral of limits negative infinity to infinity exponent st times f as a function of s dt. Yeah, some of the applications of Laplace, we have the ventilation, air conditioning systems, and radioactive decay in nuclear physics. Yeah, those are the applications. So it's key. We not only study math just to study, but it's also important that we apply it in field and we understand how it's applied in field. Yeah, I think I'm done, but if you have any questions, you can drop them in the comment section and I will get back to you at the end of this discussion. Yeah, let's see. I'm going to call my other colleague to explain the examples, and you're going to understand more in the examples. Yeah.